Hey guys, it's Andrew here, and in the last video we went over some of the problem sets that are available to you for practice. In this video we're going to take a look at converting the number 100 to its binary format, and we're also going to take a look at the number 42 and convert that to its binary format. So let's get started. So to start it out, we're going to actually build out our table here. Now I suggest moving forward, if you didn't do so when you were practicing, that you actually go through and you create this table every time, as it makes it easy. Now, of course, if you're going to go on and get like a certification, you're going to want to memorize this table. In the past, when I took my CCNA, I actually just sat down. You get like one piece of paper to write on, or like a little grease pad or board or whatever they give you. They give you like just one little piece to write on, and the first thing I did is I sat down and I wrote out this table, so if I came across any subnetting questions, I could quickly work through the subnetting, and I used this as a reference, right? If there was any conversions between decimal and binary addresses. Okay, so let's build out this table. Now, generally speaking, again, this is a base 2 system, so we could say 2 raised to the 0, 2 raised to the first, so on and so forth, but you've seen it enough times now where you can start to memorize just the numbers in their different positions. So I'm going to put my numbers in those positions. So we're going to say 2 raised to the first is 1, 2, 4, 8, 16, 32, 64, and 128 respectively. All right, and we can actually just build this table that we normally do right around this guy here. So we can go like this, right? Boom, 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 boom. All right, and there's our table all written out for us. So remember, this is 2 raised to the 0th, 2 raised to the 7th, most significantly significant. All right, we have a value of 100, and we are now going to start working through the table. All right, so remember, at this point, if we want to go from a decimal to a binary number, we need to work left to right from the most significant values, comparing our initial starting value and all tested values afterwards to each positional argument here. So we're going to say 100. All right, and is that, is it greater than or equal to my first value of 128? Nope, it's not. All right, so it's false. We're going to give this position a 0. Move on to the next one. Is 100 greater than or equal to 64? Yes, it is. Okay, so we put a 1 here, bring this down here, we subtract 64 from 100, and we should have 36. Okay, and then we move on to the next one. Is 36 greater than or equal to 32? Yes, it is. Put a 1 here. You don't have to write this out. Over time, you can just kind of say it to yourself. So is this one greater than that one? Yes, no, yes, no. And you can go down through the list and just kind of keep a running tally of what your new tested value will be. But I'll write it out for you so you can see it. All right. So minus 32, that gives us a value of 4. And then with 4, we can say, is 4 greater than or equal to 16? No, it's not. What about 8? No, it's not. Is 4 greater than or equal to 4? Yes, it is. 4 minus 4 is 0. Right? So, 0 is obviously not going to be greater than or equal to 2 or 1. So we have a 0 and a 0. So our total binary value for the number 100 is 0, 1, 1, 0, 0, 0, 1, 0. Okay, so let's get this out of the way, and let's take a look at the number 42. All right, so number 42. Once again, we're going to take a look and we're going to go through the list. Now, we can kind of use a little bit of a cheat here at this point in time, right? We're starting to get used to comparing that decimal value to our decimal values up here, and we can clearly see that 42 is not bigger than 128 and it is not bigger than 64. So we can right off the bat and say, yep, those are definitely zeros. All right, we can skip right ahead here. So 42, is it greater than or equal to 32? Sorry for my bad writing here. Yes, it is. So minus 32, give me a value of 10, put a 1 here, And then I'm just going to start skipping through pretty quickly. Is 10 greater than or equal to 16? No, it's not. Is it yes to 8? 10 minus 8 is 2. Greater than or equal to 4? No, it's not. 2, yes it is. 2 minus 2 is 0. And we get a value right there. All right. Again, if you're ever unsure, you can just work your way backwards, right? And we can turn around and we can, let me get rid of this stuff in the middle here. Quickly just, erase this out. All right. And then we can always work our way backwards and we can say, all right, 128 times 0, right? 128 times 0 plus 64 times 0 plus 32 times 1. Now you see there's 16 is a 0. So plus 16 times 0 plus 8 times 1. Right, remember this method. Plus 4 times 0. And we're going to kind of spill over here a little bit. Plus 2 times 1 plus 1 times 0. Or if we bring this all together, that's a 0. 0 plus 0 plus 32 plus 0 plus 8 plus 0 plus 2 plus 0. Or if we keep on breaking it down, 32 plus 8 plus 2 equals, well, 40 plus 2, take these guys here, equals 42, right? So I can work backwards and forwards either way, okay? So my final result was 0, 0, 1, 0, 1, 0, 1, 0. Okay, so my final conclusion here is the number 100 in decimal, the decimal number 100 in binary is 0110010. Hope I got that right. And then, of course, my number 42 is 0010110. Okay, in binary. So there is your first set of problems. In the next video, we're going to take a look at our conversions where I gave you a binary value and you're going to convert it back to decimal.